Hi again, this is the third module in the Getting Started with the Electric Drives demonstration platform series. This time we're going to move off theory and into hands-on application by building electric drives with Xilinx SDSoC. As we've mentioned in previous videos, Zynq is an all-programmable system-on-chip produced by Xilinx and best-in-class for electric drive applications. SDSoC is a tool from Xilinx that lets you take your C or C++-based design and migrate some or all of the design from the application processor system to the programmable logic. And it builds the infrastructure to communicate and move the data between the two domains for you. In the last module, we saw the overview of the eDDP hardware and design flows. We encourage you to check out the previous module before engaging with this module. The aim of this training module is to create a complete build of the eDDP example design from the C++ source code using SDSoC, and also to show the ease of the SDSoC tool for building the field-oriented control server application. In other words, the easiest way to create a motor control design in a Xilinx device. Each step involved in the build process has been elaborated to give the user a better understanding of the tool as well as the build process. Once you understand the build flow and also the algorithm implemented, you can choose to edit the source code and rebuild the design to obtain different behavior from the motor. Lastly, going through this flow will provide the user with all the necessary files to upload onto an SD card and run the application. The first step is to ensure that you have the required software and example design package for this module. This module is demonstrated using Windows, but if you are using the SDSoC GUI in Linux, you'll only see minor differences, so don't worry. You will need two items before you can start building the eDDP example design with SDSoC. First, you'll want to download and install Xilinx SDSoC version 2017.1 from the link shown here. SDSoC uses Vivado HLS behind the scenes to generate the hardware implementation, and you'll want to make sure that you use version 2017.1 for the best results from this module. The second thing is to download the eDDP package. This package can be found on the link shown here via the Xilinx GitHub page, which is a free open source package. Click on the download button to download the .zip package. Once you have the package, extract it to a known location. In this demonstration, I've extracted it to a directory named eDDP under the Documents folder for ease of access. Good job! Now you have everything you need to get started. From the Start menu, click on Xilinx Design Tools, SDX IDE 2017.1. SDSoC is part of the SDX development environment. A pop-up will appear asking to provide a workspace. This is a location where the projects you create and build will be stored. Note, you can assign the same directory as the extracted source package for easy management. Click on OK and an IDE will open up. The next step in the build process is to create an Sdx project. For this step, click on File, New, Other. Once you select Other, a dialog box will appear. From the different options, select Xilinx, Xilinx Sdx Project, and click on Next. Now, provide a name for the project. I recommend FOC Build and click Next. The next step is to provide the project platform details. Sdx has a list of standard platforms, but for this project, we will be using a custom platform. Click on the Add Custom Platform button. To add the custom platform, navigate to the directory where you extracted the GitHub package. Then navigate to IIoT-eDDP-master SDSoC platforms RDZ7 10FOC. Note, you'll want to select the whole folder named RDZ7 10FOC. Then click on OK to add this package to the list of SDX platforms. Now the custom platform will be added to the existing SDX hardware platform list. Select the custom hardware you just added and click on Next. This screen provides an overview of the software platform and the target. This window is already pre-populated from the information available in the custom platform we added. The system configuration is Linux running on the Zynq 7000 SoC with the dual-core A9 processors. Click on Next. The last step in creating the project is choosing a template. Sdx provides available templates after reading the custom platform we added earlier. For the purpose of this build, we will choose a field-oriented control with the web user interface template and click on Finish. Note, we need to add the DL library to the linker flags as seen on the right side of the screen before building the project. We'll do this shortly. Once a new project is created, you can view the project settings as seen on the screen. Project settings are essentially the overview of the project. You can also take a look at the different settings to make sure everything is as desired for this project. Make sure the Generate Bitstream and Generate SD Card Image options are selected. These two options are essential for creating the necessary files for running the demo successfully. On the left side of the SDX IDE, you will see the Project Explorer. The Project Explorer tab gives an overview of the project files. You can view, add, remove files as needed using the Project Explorer. Right-clicking on the project name from the Project Explorer will show all the different options available. Click on the C++ build settings from the options listed. This will open up a pop-up window. In the window, select Settings, SDS++ Linker, Libraries. Click on the plus button on the Libraries -L tab. Enter DL and click Apply. Click on the OK to close the window. This step is done to set the DL linker flag for the build process. Finally, we're at the actual build step. Right-click on the project name from the Project Explorer tab. Click on Build Project from the list of options. The build process has started. Wait until the build is complete. Now, take a look at the Project Explorer tab once the build process is completed. A new folder called Debug will be available. Clicking on the expand icon to the right of Debug will expand the folder. You can see a folder called SD_card under Debug. This folder contains all the files needed to run the application on an RDZ7 board. These files can be obtained from the workspace directory where you created the project, workspace directory, project name, debug, then SD_card. So far, we've walked through the steps to build an eDDP example design project using SDSoC. Now we will try to change the source code and rebuild the design. For this, we'll be working on the source code file called foc.cpp. This file contains the functions implementing field-oriented control. This file can be found in the Project Explorer tab by clicking on foc_build, then src, then foc.cpp. Initially, the code was implementing sinusoidal pulse width modulation for controlling the motor. We'll be changing the code to implement sinusoidal vector pulse width modulation, which can make the motor run 20% more efficiently. This change can be done directly in the Xilinx SDSoC tool, followed by rebuilding the project. Now let's walk through the change to be implemented. To convert S Pwm to Sv Pwm, we need to calculate Voff and subtract it from Va, Vb, and Vc. The mathematical equation to calculate Voff is added to the existing code as seen on the screen. Rebuild the project by right-clicking on the project name and selecting Build Project. Now wait for the build project to complete. Now we have the SD card files for the field-oriented control application implementing sinusoidal vector pulse width modulation. Thank you for listening, everyone. We successfully saw how to build the electric drives demonstration platform example design using Xilinx SDSoC, and also how to implement changes in the source code. Don't forget to check out the next module. It will cover the steps involved in running the demo once the SD card files are available. Also, the link to buying the eDDP kit is included in the video description below.